So today we're going to talk about properties of square roots and operations with square roots, and this is really a review of Algebra 1 stuff and even pre-algebra stuff that you covered in 7th and 8th grade. But we want to touch on it again just to jog your memories because it'll be really important as we move forward working with quadratics. So here I have the square root of 54, and my goal here is to factor it. And remember, to factor something is to break it down. So if I'm going to factor, that means I'm going to break it down into terms that will multiply to the original. 54 is the original. So I'm going to break it down into terms that will multiply to the original. So what multiplies to 54? That's how I factor. Okay, and sometimes I'll do a T-chart. You guys will remember this. So I'm going to factor 54. Well, I've got 1 and 54, but that doesn't really help me break it down. So let's go 2. So I can factor this using a factor tree into 2, and whatever number goes into 54. So 2 times, goes in there twice, goes in 14, 7, 2 times 27. 27 can be broken down. 2 cannot because it's prime. So I'm going to box 2. We're done with this side of the tree because that's prime. 27 can be broken down into 3 times 9. 3 is prime. We're done with that side of the tree. 9 can break down into 3 times 3. And now we're done with each of these sides of the tree. Okay. And what's important to know is that each of these is within a radical. Each of these things that we've multiplied by is within a radical, because the 54 is within a radical. So now I have these terms, all the boxes. So root 2 times root 3 times root 3 times root 3. And if you remember, a square root is the opposite of squaring. So when I go ahead and I multiply these back together, I end up getting 2 times 3, which is square root of 6. And then I get 3 times 3, which is square root of 9. Well, the square root of 9 I know the solution to. The solution is 3. The square root of 9 is 3. So my final answer is the whole number followed by the rooted number, which cannot be simplified. So 54 fully simplified is 3 root 6. Let's try another one. 98. So again, I begin to factor tree this. I know that 2 goes into it. I'll start with 2. So I have 2. That side of the tree is done. And remember, it's in the square root. Times, 2 goes in there 4 times. 2 goes into 18 9 times. Times 49. And this is in the square root. I can factor this as 7 times 7. And these are also prime, so they're the end of the factor tree. And now I have root 2 times root 7 times root 7. Well, 7 times 7 is root 49. What's the square root of 49? It is 7. So now I have root 2 times the square root of 49, which is 7. So I have 7, that's my whole number, followed by my root, which is 2. So 7 root 2 is how this simplifies. If you notice a pattern, if you see pairs, you know that they'll simplify. Same thing in our first example. If you see pairs, you know that they will simplify. Let's move on to our next example. In this example, we're multiplying radicals. So I'm going to go ahead and just multiply. 5 times 15. 5 times 15 is 45. So I have square root of 45. Now that I have the square root of 45, I'm going to go ahead and factor that. So 45 is the same thing as 5 times 9. And 9 is the same thing as 3 times 3. This is the end of this factor tree because it's prime. Same thing here and here because 3 is prime. And I have root 5 times root 3 times root 3, which is root 5 times root 9, which is really just 3. So my final answer, I'll come up here to this next column. My final answer is 3 root 5. The 3 simplified from root 9, and I'm left with the root 5. So again, I multiplied first, then I did the same thing with my factor tree. So I'm going to go ahead and move on to this next example. And what I want you to see in this example is that we're using multiple terms now. So we've got a 5 plus 3. This is almost like distribution. So when I multiply, I go ahead and get 5 times the square root of 15. Now a common error, which I'll do in blue, would have been to say, oh, this is 15 times 5, so that becomes the square root of 75. Well, that's wrong. This is wrong. Because this is a square root and this is a whole number, you can't multiply them. You just place them. You can multiply them. You just place them together, but you don't actually multiply the numbers. So if I continue on, I've got 15, square root of 15 times 3 times the square root of 10. So I have this first term plus the 3 goes out front because it's a whole number. There's no other whole number to multiply by. And then the 15 and the 10 are multiplied together because they're both radicals. They're both square roots. So this becomes 150. I continue on with these, and I'm going to go ahead and simplify these. So I'll bring them down, and I'll just say, well, this is the same thing as 15 times radical, 5 times radical 15 plus 3 times radical 150. And 150 I can begin to factor. So let's just begin by saying, well, it's 15 times 10. 15 is the same thing as 3 times 5. And 10 is the same thing as 2 times 5. Again, these are all radicals. And so now that I have these primes, 3, 5, 2, and 5, I can bring them down and multiply them together. I have a pair here, so I know that this is going to be root 6 times root 25. The square root of 25 is 5. So my final answer will be 5 root 6. That's the simplification for this first one. Okay, so I have 5 root 15 plus 3 times 5 root 6. So now I have 5 root 15 plus 15 root 6. If I simplify 15, all I have is 3 and 5, neither of which will do any further reduction. When I multiply them back together, it's back to 15. So this is my final answer. Now I'm subtracting. I have negative 1 54th minus 3, so that becomes negative 4 root 54. And I can factor 54 into 9 times 6, which I can factor again into 3 times 3, and 3 times 2. These will become square root of 9. These will become square root of 6. And I get 3 root 6 as my factor. So when I put it back in, I have negative 4, the original, times 3 root 6. And I end up with negative 12 root 6 as my final answer. Now we'll add. Because these are different terms, root 24 and root 6, I cannot combine these. But I'm going to factor 24 and see if I can't make it work. So when I factor 24, I end up with 3 times root 4 times root 6, root 2 times root 2, root 3 times root 2. So this pair will become root 4 times this pair, which will become root 6. The square root of 4 is 2, so I have 2 root 6, and I'm multiplying it by this 3. So now I have 6 root 6 plus 2 root 6, which becomes 8 root 6. So just some basic operations, a review of what you've seen in algebra and 7th and 8th grade. Good luck on the homework. You'll have all these different styles on there, so you'll want to pay attention. Are you multiplying? Are you adding? Are you subtracting? Are you multiplying radicals? Are you multiplying constants? how do all those things intertwine together?